what should be a good one? I feel like
You even lost
touchdowns in like 4 days.
I'm just saying I should get the reward for taking all my meds for 2 days. You know how much that takes energy out of me to do that? Go through my mini pharmacy and all of them.
Why do I still see half of the room without their stuff out? It would also be a really good idea to have multiplication chart in front of you, or if you have your old listing of perfect squares. Y'all remember simplifying radicals? Okay. Way back when, section 1.4, I think, you would have a listing of perfect squares. Some of you did it on a separate note card, some of you just had it in your packets. Or it's the diagonal, that highlighted yellow diagonal, on your multiplication chart. Okay. So we all need to have that out. Well, the last couple of goobers are getting themselves situated. Y'all are missing some tests. Get it done. Okay, today is Spartan time again. Get it done. If you didn't finish a test, if you are missing a test, get it done. Don't come in and just roll commando on a test. Do the review beforehand. Okay, the videos are posted. I send them out on Remind. They're in Plan Book. Go through the review, get yourself situated, then come in and do your test.
Can I come during Spartan time and do the review and then after school do the test?
Not today.
How about tomorrow?
I think so.
Okay.
So, if you are one of those, I know some of you, and grades looking a little rough right now because you are missing a test. Okay? If the world cooperates for a little bit, I'm hoping to get to your packets tomorrow during my White 2 prep. So, everyone got your stuff open. I know that we left off with 4.5 and now it says 4.7. That is intentional. 4.6 in this curriculum is a type of factoring that I don't want to go to. Okay? I'm not going to mess with it. Instead, at the end, I'm going to add my own version of 4.6 and 4.8, which is going to be our quadratic formula. I already went through it on Friday last week, but your calendar for the last 5 weeks is up there. You are blue. 4.7 today, it should not take very long. In fact, 4.7 and 4.6, pretty easy. As long as you have your perfect squares either memorized or on a resource in front of you. Next week, we will do quadratic formula and a little bit of prob stats. Quiz the week after. 3 days of review. Final. Okay, it is a coming. As I had said before, we got 1 day to wiggle, the other class not so much, where I would intend to do your final on the 19th. So the 23rd in this class is just going to be a FUBAR day, and then on the 24th, when you are scheduled to be in here block 2, as long as you are satisfied with your grade, you're passing, or C and above, whatever you're aiming for, I ain't looking for you, okay? Now, if you are under that mark, if you are not passing, then you would be using the 23rd and 24th to get your pooping group, okay? So, here we go. the last couple bits. When we were doing all this factoring business, there's some special ones. For example, if I had said something like, what if I said x squared minus 24x minus 25? Just a scratch chunk of paper somewhere, the back of a page. Factor that for me, please. Because it's going to kind of lead into what we're doing today. So I don't care where. Do it on your Starbucks wrapper. I don't care. Just, I want you to factor this. Remember, write out all your factors of negative 25. What times what makes negative 25? Write them all out. And then you find the magic pair that adds up to a negative 24. I would like you to write them all out this time because it's going to relate to what I do with it afterwards. Okay. List all your factors of negative 25. Which of them add up to a negative 24? I just got heebie-jeebies. You can get that shiver up your back. I got that warm, cold thing going on. Happens with sleep deprivation.
I always get that when I think about spiders. I'm not like scared of them, but like when I just think about them like crawling on me.
Yeah. Fuzzy legs. The list is pretty small, right? That's it. Those three. Which pair adds up to negative 24? Okay. So if you get your magic pair, you would say x minus 25, x plus 1. What we're doing today is special ones. What if I said just that? And we're like, something's missing. Why is it smaller? Okay, just like when we were doing linear equations. Remember with linear equations, if I had y equals mx plus b, and if I said y is 3x. We panicked a little bit until I said, don't worry about it. Or if I said y equals 5. You're like, what do I do? Put a 0x in there, right? What's missing from this? The middle term. It's always x squared plus bx plus c. There is no middle term. So what can I put there? A 0x. And then x squared plus 0x minus 25. Good thing I already have them written out. Which of those adds up to 0 in the middle. 5 and negative 5. Okay? And it becomes a special format. X plus 5, x minus 5. These are called conjugates. Conjugate. Any of you in English or one of our foreign language classes remember conjugating verbs? Okay. Conjugate means to go with. These are called conjugates because they go together in a very special way. They are what create, see how this is a square and this is a square? X times x is x squared. 5 times 5 is 25. And I'm subtracting them. This is called a difference of squares. Look at the top title of the page. Section 4.7. Factoring difference of squares. They're going to have a special form where I don't even need to do the factoring. Because it's nice and simple. I square root this guy and put it there. I square root this guy, I put it there. Plus minus, done. Square root this, plus minus, I win. That is how we factor difference of squares. I don't need to do the full version of this anymore. I can say something like x squared minus 144. I see there's no middle term. It's a square minus a square. So it's going to have this plus minus pair. And I say the square root of this guy is x. And the square root of this guy is, because 12 times 12 makes 144. A negative 12 times 12 is a negative 144. Negative 12 plus 12 is 0. The only way I'm going to end up with no middle term is to have two things that add together to make 0. If they add together to make 0, they got to be the same thing. 6 plus negative 6. 10 plus negative 10. They've got to be the same. And if they're the same, that means they're squares. Okay? So if you've got that perfect square list, remember 1 squared is 1, 2 squared is 3 squared is 4 squared, 5 squared is 25, and then 36, 49, 64, 81, 100. If I go over into the teens, we should have 121, 144, 169, 196, and it keeps on going. 225, 289. Oh, skipped one. Tired. 256, 289, 324. Isn't 324 in there? Yeah. 361 and then 400. Come on, y'all. I'm running on like 4 hours of sleep. You got... yeah, fine.
Yay!
Okay. I should know better. Okay. So, if you know your perfect squares, here we go. That's all this says up top. This is the proof using just variables. I know that using just variables is pretty abstract. It's hard to wrap your head around it. So, don't worry about all that part. Can you follow this? Square root of x squared is x and x. Square root of 64 is 8 and 8. Plus minus pair. Okay? Here we go. Whoop. Come on, Frank. Let's go, Frank. So when I say factor y squared minus 36, I'm going to take those two pieces. The square root of 36 is 6. The square root of y squared is y. So it factors into a y here and here. Come on, you. A 6 here and here. And in between, it's a plus minus pair. Frank.
He's having a tantrum or something.
All right. That's my answer. Y plus 6, y minus 6. It's done. But they want us to check to make sure that we did this right. So if I have y plus 6 and y minus 6, we're going to go to distribution town. Y times y is y squared. Frank, come on. Y times a negative 6 is negative 6y. 6 times y is plus 6y. And 6 times negative 6 is negative 36. Look what happens in the middle when I combine like terms. Okay. Negative 6y plus 6y. Bye-bye. Trace, do we need to set you somewhere else? Just kind of like everything's converging on you right now in terms of attention.
What I do? You're distracted.
Okay. Those middle terms will cancel out. This is how I end up with no term in the middle, also called a 0y. So, okay, yeah. Frank? Frank being slow. All right. Now, this one's got a little more oomph to it because we have not yet had a number in front of x squared. That's why I cut out the normal 4, 6. Normal 4, 6 has numbers in front of x squared, and it really messes with things. Okay? I'm going to show you quadratic formula later. For now, I just noticed that this number and this number are both on my perfect square list. And I'm subtracting them, so that means it's a difference, subtraction, of squares. Difference of squares has special form. Special form says, I do the square root of this guy. What's the square root of 25?
5.
Square root of x squared. So the square root of 25x squared is 5x. Just like we're back in section 1.4 from September. Okay, the square root of 49.
7.
So I can write this as a difference of squares. The square root of this guy goes here and here. The square root of this guy goes here and here. That's it. That's my answer. 5x minus 7, 5x plus 7. Also, the order doesn't matter. What I can't do, you got to be careful about this. I can't say 7 minus 5x and 7 plus 5x like that. Because now I would have a positive 49 in the front and a negative 25x squared at the back. Okay? So I can change the order of these. I can't change the order inside. Cool? All right. Disturber. I suppose they want us to write it again. Fine, I'll write it again. We have a 5x plus 7 and a 5x minus 7. And right. Y'all know these smart boards are older than you, right? Okay, 5x times 5x is what?
25x.
25 and then an x squared, right? 5 by 5, x by x. This is the exact same model of smartboard that I used during my junior field experience in Flagstaff, Arizona in 2005.
I'm the same age as Frank.
My brother's older.
Dude, I'm like really the same age as Frank.
Okay.
I feel very not.
Then 5x times, careful, 5x times negative 7 is a negative 7, not negative 7, negative 35x. Keep going, keep going, keep going. 7 by 5x is plus 35x's. And 7 by negative 7 is minus 49. Look at those four terms. Which of them can go together? X to the first and x to the first. You owe me 35 waffles, you give me 35 waffles. Poof! The slate is clear, 0 waffles are owed. So I'm now at 25x squared minus 49, which is where I started. Remember that from here downward, that is the check. My answer is those two binomials above it. Okay? So as long as you know your perfect squares, or have those written in front of you, you good to go. Frank, buddy, we don't have to do this every time, dude. All right. Now this one, there's a third example. I want you to look down your perfect square list for these two numbers. Ruh-roh. Now, these are not perfect squares, but we learned how to do GCF factoring, greatest common factor. So, they don't leave us much room here because they expect that we're going to be able to just kind of mental math our way through that. If that's not the case, don't worry about it. Off to the side here. How do I break up 27? 3 and 9. 9 is? Okay, so I will write 27x cubed as 3, 3, 3, 1, 2, triple x. I will write negative 48x before even that. Remember, we split our negative 1 off so that we don't forget it. Negative 1 by 48, and then you said 2 and 24? What times what makes 24? 2 and 12, 2 and 6, 2 and 3, if you just want to keep writing those two stairs all the way down. So I'll write that out as negative 1 by 2 by 2 by 2 by 2 by 3 by x. We just did a test like this, right? You break them up. If there's a negative, make sure that you put that negative off to the side. What do these two have in common? Do they got a negative in common? Okay, they both got a 3 and a x. So the first line up here, they didn't give us room for that. I'm not a fan of that. Is I've got a 3x and a 3x. If I take that 3x out, you see what's left? Purple, 3 times 3, x. I'll call it 9x squared. Down here I've got a negative 1, 2 by 2 by 2 by 2. Remember, 2 times 2 is 4, times 2 is 8, times 2 is 16. So minus 16. Frank? So the very first line, they just expected that you could take those out through mental math. I don't think that's very fair. If you got to write it out off to the side, you write it out off to the side. Okay? It's important that you take out the GCF because now, look at that purple-blue business. 9 and 16. Where are those numbers? They're both on that perfect square list, right? So, the 9x squared becomes 3. Don't forget your x with it. And you said the square root of 16 was 4. So since this breaks up into 4's here, 9x, no, not 9x's, 3x's. There we go. To fully factor this thing, I needed to combine both today's skill and the GCF factoring from like 2 weeks ago. I'm going to have my 3x there. I'm going to have my 4's here. And don't forget your kid brother at Burger King. Put that 3x out front. Okay? Because we factored it out. We took it out of here and here. It's still a part of my problem. I just set it off to the side so I could find my perfect squares. Okay? You ever pull apart your burger to find that they put a pickle on there so you can throw the pickle out and then put it back together? Okay? You have to take out the GCF and you set it off to the side. Just because you don't like the pickle doesn't mean that maybe he wants to eat the pickles. Okay, you take the stuff off your burger, set it off to the side, and give it to him. Okay, you don't just throw it away, you put it off to the side for later, or for your buddy. Now, if I'm going to check that, that's where we got to remember old school distribution. If I have a 3x plus 4 and a 3x minus 4, and I go distribution bonkers on that, I'll end up with a 9x squared minus 16. Look at what happens when I distribute into it. So bringing it all the way back to the beginning of chapter 4, like a month ago. What's 3 times 9? X times x squared. 3 times 16. 48. X on the end. I end up with 27x cubed minus 48x. That's why I couldn't leave my kid brother at Burger King. Because otherwise, you'd get home at 12:30, pull into the driveway, and wonder, where's Ian? Okay? You have to have that 3x there so you can check it at the end and make sure you got all the way back to where you started. So, these are going to come later. We're going to practice the other ones first. I don't. You're trash.
Why are you always so mean to Frank?
Frank's been mean to me. I give what I get. Frank needs to retire. It's that simple. Frank should have retired 10 years ago. So, numbers 1 and 2, go. Numbers 1 and 2, go. Those ones are nice. You just find them on your chart and you're good to go. Something like that.
I'm like roughly the same age as Frank.
Mm-hmm.
I don't like that.
I mean, you're younger than me.
I'm just saying Frank is old.
You're also not technology
I know.
Yeah, and
Neither
Frank
is you.
that you know of.
And I crack every one of my guns.
11 and 11.
Okay, so those ones are pretty easy, right? You just look them up. The square root of x squared is x. The square root of 25 was 5. This was the very first thing that we started with. The square root of y squared is y. The square root of 121, I hear from a voice in the back, is 11. Now, if you wanted to check those, you would just distribute, FOIL, box method, spaghetti arrows, whatever your jam is. Okay, I'll walk you through another one of these GCF guys. So,
Go. It's good.
Three and 192, are they on your perfect square list?
No.
Nope. So, off to the side, I need to say, can I break up 3?
No.
Nope. It just is 3 times A times A. What about, Frank? Negative 192. Well, I better take the negative off of there to start with. What goes into 192? I know there's a 2 in there at least. So 2 times what? Do 192 divided by 2. Okay. How do I break up 96? Oh, I know it's got to have a 2 in there again. With 48. And then I heard a 2 with 24. I heard a 3 with an 8. I heard a 2 with a 4 and a 2 with a 2. Remember, you're only looking at the ends of the branches. I'm kind of all over the place because I'm up at the top of the screen here. But, hold up. End of the branch, 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 end of the branch. That's right over my orange thing there. Okay. All of that stuff no, not you, is -1 by 2, 2, 2, 2, 2, 2, 3. All right, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. What do these have in common? Just a 3. Just a 3. All right. Well, if that's all we got, that's all we got. So is there a GCF to factor out? Yes, it's a 3. If I take the 3 out, show me what's left. A by A, a negative, what is 2, 2, 2, 2, 2, 2? Negative 64. And then everyone sees a 64 right below it, and they're like, oh, facepalm, right? So then, take those in their pieces. We'll go to this. Square root of A squared is? A. Square root of 64 is? So I put 8 here and here. Again, I've got the A's and the 8's, the plus minus pair. So the final answer has the plus or minus 8, the A's, and don't forget your kid brother at Burger King. That 3 is out front. Okay. Now they want the check. We said 3 by A plus 8, A minus 8. If we disturb that stuff, Frank, dude. Okay, what's A times A? A times A.
A squared.
A squared. A times 8. Negative 8A. 8 times A. 8A. And now 8 times negative 8 is negative 64. Do any of those terms combine? Negative 8A and positive 8A will combine. Getting A squared minus 64. Cool, we're headed back the other way. It means we're doing it right. Now I disturb it. Take 3 times A squared and I get 3A squared. Take 3 times negative 64. I should get a 192. Grab a calculator and check. Okay. So again, our answer was back here. That was just the check to make sure. I multiplied it all out to make sure I did it right. So this is kind of taking all of the stuff all the stuff we've done this chapter. Our GCF factoring, our multiplying, our looking through our multiplication chart for factoring binomials, all of that stuff, just kind of tossing it into a blender and seeing what happens. Four and five. 4 and 5. They only give you room for the answer at the end. You're probably going to have to do your work off to the side. If you want to do it on a scratch sheet of paper, something. but the first thing you do, break them up and look for that GCF, just like we did a couple weeks ago. Okay, if you get a little fuzzy on that, it's no problem to work with your neighbors, so long as we're working. Okay, but you gotta take out your GCF first. That's called factoring completely. Okay. If I break up those first two, they've got a pair of 2's in common, which is 4. That's why they have a 4 next to these parentheses. They told us you're going to take a 4 out. So if I take a 4 out of 36x squared, 3 by 3 is? There's a 9x squared left over. What happens when I take these out? Sorry, this is kind of... Yeah. Oh, remember, there's a -1 there. There's always the 1 as a placeholder. Also, if I break that -1 off at the beginning. Okay. So... Oh, Frank, I'm so glad to be rid of you. We're going to have a 9x squared minus 1. Okay, those are perfect squares. Go to your list. What's square root of 9x squared? A 3 and a x. So 3x and a 3x. Not squared on both because x times x is what makes x squared. All right, really tough, like top tier question here. What squared makes 1? Dude. Okay. So 3x plus 1, 3x minus 1. They leave the 4 out front. Now 169 and 49, if you broke those up, they got nothing in common because it's 13, 13, 7, 7. That's it. But those are perfect squares. What is the square root of 169? Y's. 13 Y's, 13 Y's. What is the square root of 49? There you go. So sometimes you can take something out, your GCF. Other times, they're just perfect squares as is. Now, I want you to come back here. Wasn't 36 and 4 also on my perfect square list?
Yeah.
So watch this. If I said, well, that's a 6x minus 2 times a 6x plus 2. You see how these two guys got a 2 in common? And these two guys got a 2 in common. So what happens if I take a 2 out of both of them? I've taken a 4 out of the entire thing, leaving a 3x and a 1, a 3x and a 1. Which is the same as what if I gave this guy a 2 and gave that guy a 2? I would end up here. So there's a difference between I factored it versus I completely factored it. Oh no, they put words with it. This is a very, very common type of problem. You may remember from middle school. You'll absolutely see it in geometry. I call them the donut problems. When you're trying to find the area with a piece missing. Nice and simple. You take the area of the big guy minus the area of the little guy because it's gone, right? It's like the whole cake minus one piece. You ever have someone do that to you with a cake? Just like cut right in the middle and take that piece out?
Sometimes just to irritate my brothers.
I did that with the brownies to one of my classes. I just like cut a diagonal brownie right in the middle and just ate that in front of them. All right? Ooh, there you go. Okay, so looks like Samir's got a, what is that? Probably just sheet of plywood. The sides are S and S. The itty bitty one in the middle is 4 by 4. Write an expression to model the area of the remaining wood. Well, how do you do the area of any rectangle? Base times height, length times width. If it's a square, isn't it side squared? Because it's times itself. So the area of the big one is just S squared. What's the area of the little one? 4 by 4 is 16. 4 squared, 16. So the area of the entire thing is big guy minus little guy. That's it. S squared minus 16. Turns out words aren't that hard. Most of the word problems that we get in this curriculum, aren't they usually just blah, 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 do the same thing? Okay?
In my defense,
Half the people in this room are.
so half of us words are dumb hard.
Yes.
I can't
Flip it over. Page 166. Take a look at what we got. Uh-huh. And you have a whopping 42 minutes.
Yippee!
I told you, today wasn't bad. Get working.